Hello everyone, welcome you all to another video on set theory. So in this video, we will be discussing the different laws of algebra of sets. Why is it called laws of algebra of sets? Because the different algebraic laws like commutative law, associative law, which are already there in algebra, can also be used in set theory. So we will be discussing the different laws of algebra. So let's start with the first one. The first law is called the idempotent law. Idempotent law. In the idempotent law, it is such that A union A will be equal to A and A intersection A is equal to A. So this is called idempotent law. Next is the identity law. Identity law. So what is identity law? Means they will give us the same set. So A union null will give us A union null will give us A, and A intersection universal set will also give us A. So that is called identity law. It is called identity law because we get the same set. The resultant set is the same set as the input set. So identity law. Next is the commutative law. Commutative law. So commutative law is A union B is equal to B union A. Similarly, A intersection B is equal to B intersection A. So this is called commutative. For example, in case of addition, A plus B is equal to B plus A, and A B is equal to B into A. Similarly, in commutative law, for set, it is A union B equal to B union A, and A intersection B is also equal to B intersection A. Next is the associative law. Associative. So in the associative law, it is A union B union C will be equal to A union B union C. So here A union B and here B union C. Parenthesis is being used. And similarly, A intersection B intersection C will be equal to A intersection B intersection C. So this is the associative law. Next is the distributive law. Distributive law. In case of distributive law, it is A union B intersection C will be equal to A union B intersection A union C, and the other way is A intersection B union C is equal to A intersection B union A intersection C. So here we have seen that distributive law, the name itself suggests that A gets distributed with B and C. So A is getting distributed with B, A is getting distributed with C. Similarly, A is getting distributed with B union A is getting distributed with C. Therefore, it is called distributive law. Next law is the complement law. How is the complement law written? So complement law. A complements complement will get A. If we take the complement of another set, we get the original set, that is A. Similarly, another A union A complement will give us A union A complement will give us the universal set, and A intersection A complement will give us the null set. So intersection A complement is the null set. So that is the complement. So under complement there are three rules. Next is the next law, another law of set in set theory is De Morgan's law. De Morgan's law. So in this there are two variations. The first one is A union B whole complement is equal to A complement intersection B complement. Another variation, A intersection B whole complement is equal to A complement union B complement. And you observe that in this case, union complement is equal to intersection individual components. So on the right hand side it is intersection, on the left hand side it is union. For this case, left hand side it is intersection, on the right hand side it is union. So De Morgan's law, that is called De Morgan's law. So relation to the basic laws, there is another law which we will use across different problems for solving different problems. So that is called the inclusion-exclusion principle or inclusion-exclusion law. So that is another very important law in set theory. So it is number 8. So inclusion-exclusion law or inclusion-exclusion principle, we can say. Inclusion-exclusion principle is N of A into B, N of A union B is equal to N of A plus N of B minus N of A intersection B. So here means number of elements in the set A plus B is equal to number of elements in the set A plus number of elements in the set B minus number of elements in the set A intersection B. Another variation, if we take this to the left hand side, A intersection B is equal to NA plus N of B minus N of A union B. So intersection and the union. So these are variations of inclusion-exclusion principle involving sets. Similarly, we can write inclusion-exclusion principle for 3 sets. Say union B union C, it will be N of A plus N of B plus N of C. The individual sets, number of elements in the individual sets are added, minus N of A intersection B minus N of A intersection C minus N of B intersection C. We are subtracting the intersection between two of them and then we add N of A intersection B intersection C. So this is the inclusion-exclusion principle involving 3 sets. Just if we shift this to the left hand side and shift this to the right hand side, it will be almost like this. It will be N of A intersection B intersection C will be equal to N of A plus N of B plus N of C minus N A intersection B and A intersection C and B intersection C plus N of, since we have shifted this to the left, so this will come to the right. So N of A union B union C. So if you observe it carefully, we will see that the set, individual number of elements in the set, wherever the single set is there, it is plus, but sets there is minus, and wherever 2 sets are involved, there is plus again. So that means for odd number, you can remember it in this way. For odd numbers, it is addition. For even numbers, it is subtraction. Say odd number adding, odd number it is adding up, but whenever there is even, it is being subtracted. So this is the basic laws in set laws, laws of algebra of sets, and this to solve different mathematical problems. So we'll look into solving different mathematical problems by using these laws, and in many cases we have to prove these laws also. Okay, so that's all in this video. So in the next video we will look into some of the problems related to this. Thank you very much.